Under ratios, ladies and gentlemen, welcome to the wonderful world of ratios. Wait, have we talked ratios before?
Yeah.
Perfect. Then today will be same thing, just more exciting. Under ratios, we have the little subheading maybe story problems, which usually makes everybody happy.
Yeah.
Story problems.
Yeah.
But the big thing you need to definitely do here to appease the teacher and make him very happy, which is always good, is you need to make ratio boxes. So make ratio boxes, which simply means this. Here we go. Let's write down an example problem. To make green paint, to make green paint, comma, the ratio of, what is it? Blue to yellow paint. The ratio of blue to yellow paint is, anybody know what the ratio is? 3 to 2. 3 to 2. For 6 ounces of yellow paint, for 6 ounces of yellow, for 6 ounces of yellow, how much blue paint would you need? How much blue do you need? How much blue do you need? This is what I need to see for such a problem as this. Okay, have we done ratio boxes?
No.
Okay, so it's nothing more than this. You're just going to draw yourself a little box. You're going to cut it into like 4 equal sections there, and then you're going to label it. And pretty much always the top labels are going to be the same. The box on the left you're going to call, it's going to be the ratio. The box on the right is going to be the actual. And then the 2 rows are what 2 things are you comparing? In this problem, I'm comparing the green paint, I'm comparing the blue paint to the yellow paint. It doesn't matter which one you cut, I could put the yellow on top or whatever. Blue to yellow. Okay, and then you're going to take what ratio they give me. What ratio am I given? 3 to 2. What is 3? 3 is the blue, 2 is the yellow. How do I know 3 is blue? Because first one given first number, second one given second number. 3 blue to 2 yellow. That's my ratio, 3 to 2. And then they give me, they're either going to tell me the blue amount of blue or the amount of yellow. They tell me how much yellow paint, so that goes here with the yellow paint. And then, boys and girls, ladies and gentlemen, and kids of all ages, you just have to think about this as being equal fractions. And some of you may already know the answer to this. That doesn't matter because they get harder. This is just kind of like a base one. In other words, this, okay? You pretend like these, I should maybe make this. You pretend like these are equal fractions. And you say to yourself, how do I go from 2 to 6? I multiply by 3. So I also need to then multiply the top by 3 and I get 9. So that's your answer to that. 9 ounces of yellow. And this, ladies and gentlemen, this little multiplication thing there in the mathematical world is called a constant factor. Say that after me. Constant factor. Why do you suppose it's called both constant and a factor? Factor means multiplying, what you get when you multiply something together. Well, product is the answer to multiplication, but factors are the two things you're multiplying together. I multiply these two things to get that. And constant means what, Ike Shaw? What does it mean to be constant? If you are constantly late, if you are constantly happy, if you are constantly, what? What'd you say? Yeah, well, it's continuous. It's the same one. No matter what, I would constant. Constant means I multiply by 3 every time. No matter what I put over here, I multiply by 3. If my blue was 12, then my yellow would be 36, or whatever, however that would be there. Right. My blue is yellow, my yellow would be 8. You're ready for another one, right?
Yeah.
That would be about as exciting as it gets. Here, let's do this one. Ratio of boys to girls was 6:5. Ratio of boys to girls was 6:5. So right off the bat, ladies and gentlemen, here I can tell you this is how my ratio box is going to start. What am I comparing? Boys to girls. This is my ratio. This is my actual. I would love to see this on your boxes. It doesn't. You want to time me to see how long that took, Ryan Kavard? Are you whining about having to do this? You'd love to do this, right? More than life itself. You say more than life itself? Ratio of boys to girls. Boys to girls. 6:5. Well, that was like half the problem. We don't know what the rest is. The rest of the problem says if there were 60 girls, there will be trouble. How many boys? So there you would put the girls is 60. Where does that thing go with the girls? How many boys? You need to figure out what your constant factor is. Now, you may or may not know this. How do you go from 5 to 60 multiplied by 12? If you don't know that, then by all means, you can divide 60 by 5 and get you 12. But whatever anything else is, you're going to multiply by 12. 6 times 12 is 72. There would be 72 boys with bigger trouble still. Kind of get the gist of that? Doesn't sound very complicated, does it?
Yeah.
I didn't say cheer. I said it doesn't sound very complicated.